Far beyond the familiar planets of our solar system, out past Neptune's icy orbit, lies a shadowy realm that defies imagination, the Kuiper Belt. This vast, frozen frontier stretches billions of miles into the darkness, a graveyard of ancient relics left over from the birth of our cosmic neighborhood. But don't let its quiet exterior fool you. Hidden among these drifting chunks of ice and rock are mysteries so profound, they could rewrite everything we know about how our solar system came to be. Imagine a place where the light of the sun is so faint, it's little more than a distant star, where temperatures plunge hundreds of degrees below zero, and where objects from the dawn of time still wander, untouched and unexplored. This isn't science fiction, it's our own cosmic backyard, and what we've discovered there already has left scientists both thrilled and utterly bewildered. Some of these distant objects behave in ways that shouldn't be possible. They follow bizarre, looping orbits that defy gravity's rules. Some glimmer with unexpected colors, hinting at compositions science can't yet explain. And then there are those that move as if tugged by invisible forces, whispers of something massive lurking even further out, waiting to be found. Each of these enigmatic bodies is a frozen time capsule, holding clues to the violent chaos that shaped our solar system 4.5 billion years ago. But they might also hold something even more tantalizing, evidence of phenomena we haven't even dreamed of yet. In this journey, we're diving deep into the Kuiper Belt's greatest puzzles, 25 of its most mysterious objects, each with its own story to tell. From the strange, slow dance of far-flung worlds to the glint of ice that shouldn't exist where we've found it, these aren't just random chunks of debris. They're keys to unlocking secrets about where we came from and perhaps where we're headed. So buckle up. We're venturing into the frozen unknown, where every discovery raises new questions, and the next great revelation could be waiting just beyond the next orbit. Our first stop in this cosmic mystery tour takes us to Arrokoth, once nicknamed Ultima Thule, the most distant object ever visited by a human spacecraft. When NASA's New Horizons probe raced past it in 2019, it revealed a world unlike anything we'd seen before. Picture two pancake flat lobes gently pressed together like a celestial snowman, its surface painted a deep, rusty red. But the strangest part, that surface is eerily smooth, untouched by violent collisions that scar most ancient objects. This pristine condition makes Arrokoth a time machine, preserving secrets from the solar system's earliest days. Scientists believe its two lobes formed separately before gently merging in a cosmic slow dance so gently, in fact, that their original structures remained intact. This supports a radical idea about how planets were born. Instead of violent crashes between asteroids, tiny particles may have stuck together in a delicate ballet, growing slowly over eons. The reddish hue, that's likely organic material called tholins, cooked up over billions of years by radiation bombarding its icy surface. What's chilling is how little this object has changed. While planets like Earth were melted and reshaped, Arrokoth stayed frozen in time, a fossil from the era when our solar system was just a swirling disk of dust. Even its orbit holds surprises, circling the sun almost untouched by gravity's tug-of-war. It's a rare survivor from an epoch when the giant planets hadn't yet muscled into their current positions. Every detail whispers the same story. We're looking at the original building blocks of planets preserved in deep freeze. If we want to understand how Earth's ingredients came together, Arrokoth might just hold the recipe. And to think, this cosmic snowman is just the first of many strange travelers waiting in the Kuiper Belt's shadows. Arrokoth's smooth, almost unblemished surface is one of the biggest head-scratchers for scientists studying the Kuiper Belt. In a region littered with cosmic shrapnel where collisions should have left it pockmarked like the moon, this strange double-lobed object looks eerily undisturbed. The lack of craters suggests it spent billions of years in a quiet corner of space, avoiding the violent chaos that shaped most other ancient bodies. But how one theory points to its unique orbit, a gentle path that kept it far from the gravitational tug of war that flung other objects into chaotic dances. Another possibility is even more intriguing. The Kuiper Belt's outer reaches might be far less crowded than we assumed, making devastating impacts rare. Then there's the riddle of its rusty red color, a telltale sign of complex organic molecules called tholins. These aren't signs of life, but they are the chemical building blocks that could have seeded life elsewhere. Radiation from the sun, even at that staggering distance, has been slowly cooking Arrokoth's icy surface over eons, transforming simple compounds into more complex ones. What's startling is how uniform this coating is, like a slow, cosmic paint job applied with unimaginable patience. It hints that the object's environment has been stable for an almost unthinkable length of time. This pristine condition turns conventional wisdom on its head. Most models assumed Kuiper Belt objects were battered relics reshaped by countless collisions over time. But Arrokoth whispers a different story. Some of these ancient worlds might be time capsules, preserving snapshots of the solar system's infancy in exquisite detail. If that's true, our entire understanding of how these distant objects evolve or don't evolve might need a rewrite. And if Arrokoth isn't alone, there could be an entire population of similarly untouched fossils drifting in the dark, each holding secrets about how planets like ours were born. Pluto may have lost its planetary status, but this distant world refuses to be forgotten because what we've discovered there shatters every expectation. Once dismissed as a frozen, dead rock, Pluto is actually a geologically vibrant world, hiding secrets that rival anything in the inner solar system. Let's start with the most striking feature, that enormous heart-shaped glacier, Sputnik Planitia. This sprawling plain of nitrogen ice, larger than Texas, isn't just for show. It's the engine powering Pluto's bizarre weather systems. Nitrogen here doesn't stay frozen solid, it sublimates, rising into a wispy atmosphere before snowing back down elsewhere, creating winds that sculpt the landscape. Imagine a glacier so active it reshapes itself like a slow-motion ocean, complete with floating ice mountains and shifting currents. Beneath that icy heart, something even more tantalizing might lurk, a subsurface ocean. Pluto's surface shows cracks and ridges hinting at liquid water trapped beneath its shell, kept from freezing by the warmth of radioactive decay. If confirmed, this would place Pluto in an elite club of worlds like Europa and Enceladus, places where life in some form could potentially survive. The fact that a body so far from the sun could harbor liquid water forces us to rethink what habitable really means in the cosmos. Then there's Pluto's atmosphere, a fragile, blue-hued shroud of nitrogen that shouldn't exist at all. At such extreme distances, most gases should freeze solid and collapse. Yet Pluto defies physics, maintaining a cycle of evaporation and condensation so precise, it creates global haze layers visible from space. Some scientists think tiny organic particles high in the atmosphere, glowing like cosmic confetti under sunlight, are the secret to its stability. But perhaps the biggest surprise is how alive Pluto looks. Towering mountains of water ice, some as tall as the Rockies, stand beside plains of frozen nitrogen carved into polygonal patterns by convection currents. Glaciers flow, cliffs slump, and entire landscapes renew themselves over geological time. This isn't the static, cratered wasteland we expected. It's a world with its own pulse, proving that even in the Kuiper Belt's perpetual freeze, change and energy persist. Pluto's demotion didn't diminish its mysteries, it unveiled them, showing us that the solar system's outer reaches are anything but dormant. Pluto's atmosphere isn't just thin. It's a laboratory for the impossible. Picture this, a world so far from the sun, sunlight takes over 4 hours to reach it, where temperatures hover around -380 degrees Fahrenheit. Yet somehow, this frozen dwarf planet cradles an atmosphere with more layers and complexity than Mars. The most baffling feature, those ethereal blue haze layers towering hundreds of miles above the surface, like a delicate veil of cosmic chiffon. When New Horizons snapped images of Pluto backlit by the sun, scientists expected to see a faint, wispy outline. Instead, they were stunned by intricate bands of haze, each one a puzzle. These hazes shouldn't exist at all. At Pluto's distance, solar radiation is so weak, atmospheric gases should freeze and fall like snow within minutes. But here's the twist: ultraviolet light from the sun interacts with methane and nitrogen high in the atmosphere, sparking chemical reactions that create tiny organic particles called tholins. These particles scatter sunlight, producing that ghostly blue glow. What's wild is how thick and structured these hazes are. On Earth, our atmosphere thins steadily with altitude. Pluto's, by contrast, has distinct layers, almost like a celestial onion. Some scientists think gravity waves ripples caused by winds flowing over mountains might be shaping this stratification, creating pockets where haze particles cluster. Then there's the seasonal drama. Pluto's oblong, tilted orbit means its year is a roller coaster of extremes. When it swings closer to the sun, even briefly, ices on the surface sublimate, puffing up the atmosphere like a balloon. As it retreats, that atmosphere should collapse, but it doesn't vanish completely. Some process, possibly heat trapped by those very hazes, keeps it clinging to life far longer than models predict. The kicker: Pluto's atmosphere is actually increasing in density, contrary to all forecasts. Data from stellar occultations, when Pluto passes in front of distant stars, reveal its air is growing thicker, not thinner, even as the dwarf planet moves away from the sun. One theory suggests underground reservoirs of nitrogen, slowly releasing gas like a cosmic pressure cooker, might be at play. Another posits that Pluto's extreme axial tilt causes polar ices to migrate, releasing fresh gas when exposed to sunlight. Whatever the cause, this tiny world is rewriting the rules of atmospheric science, proving that even in the deepest freeze, chaos and beauty can thrive. And let's not forget the winds. Despite an atmospheric pressure 100,000 times weaker than Earth's, Pluto has weather. Nitrogen and carbon monoxide frost shift across the surface, blown by breezes too faint to feel, yet strong enough to sculpt dunes of methane sand. It's a reminder that nature doesn't need brute force to create complexity, just time, patience, and a dash of the unexpected. If Pluto, a world smaller than our moon, can harbor such intricate atmospheric ballet, what other surprises might the Kuiper Belt be hiding? Eris wasn't just another frozen world in the Kuiper Belt. It was the cosmic wrench that threw our entire definition of a planet into chaos. Discovered in 2005, this distant dwarf planet sent shockwaves through astronomy, not because of what it was, but because of what it revealed. At first glance, Eris seemed like Pluto's twin, icy, small, and hauntingly bright. But when scientists measured it, they got a shock. Eris was more massive than Pluto. That realization forced a brutal question. If Pluto was a planet, why wasn't Eris? Let's talk numbers. Eris stretches about 1,440 miles in diameter, making it slightly smaller than Pluto in size but packing more heft. Its surface, likely a mix of frozen methane and nitrogen, reflects an astonishing amount of sunlight, so much that it's one of the brightest objects in the Kuiper Belt. That high reflectivity hints at a surface constantly refreshed by geological activity, possibly even volcanoes spewing slushy ice instead of lava. Imagine a world so cold, its volcanoes erupt with frozen gases, painting the landscape in gleaming frost. But Eris's real drama lies in its orbit, a wild, stretched ellipse that takes it nearly 3 times further from the Sun than Pluto at its most distant point. For decades, this lonely world drifts in the deep freeze, only to swing slightly closer for a brief, frigid summer. Such an extreme path suggests a violent past, possibly a gravitational kick from Neptune that sent it careening into the outer darkness. The discovery of Eris didn't just add another object to the solar system map, it exploded the old way of thinking. If Pluto was the 9th planet, then Eris had to be the 10th. But what about the next similarly sized object, and the one after that? Suddenly, the idea of planets felt messy and subjective. In 2006, the International Astronomical Union drew a hard line, reclassifying both Pluto and Eris as dwarf planets, a decision that still sparks debate today. Yet Eris's legacy isn't just about labels. Its existence forced us to confront how little we truly understand about the Kuiper Belt's diversity. Here's a world brighter than fresh snow, potentially geologically active and defying expectations at every turn. If something as strange as Eris could hide in plain sight for so long, what else might be lurking in those frozen depths? Eris' mysterious moon Dysnomia might look like just another speck of light in the void, but this tiny companion is whispering secrets about its dwarf planet host that we're only beginning to decode. Discovered just a year after Eris itself, Dysnomia's orbit is oddly elongated, tracing a lazy, elliptical path around its parent body. That peculiar dance isn't random, it's a cosmic fingerprint, revealing clues about Eris' hidden composition. By measuring how Dysnomia moves, astronomers calculated Eris' mass with startling precision, confirming it's denser than Pluto. That extra heft suggests Eris isn't just a ball of ice. It likely has a substantial rocky core wrapped in a thick mantle of frozen volatiles. But the real intrigue lies in what Dysnomia's orbit implies about Eris' insides. The moon's path is tilted, a sign that Eris might be unevenly dense, with material distributed in unexpected ways. One theory, Eris could still be geologically active deep below its icy shell, with sluggish currents of partially melted ice shifting its mass over time. Imagine a world so distant from the sun's warmth, yet still churning with residual heat, perhaps from radioactive decay, or the lingering energy of its violent formation. Then there's Dysnomia's own oddities. Unlike Pluto's moon Charon, which is large enough to create a gravitational tug of war with its host, Dysnomia is small and faint, barely 1/10 the size of Eris. Yet its orbit is remarkably clean, free from the perturbations you'd expect if other unseen moons were nearby. That simplicity hints at a quiet, stable system, one that's avoided the chaotic collisions that shaped other Kuiper Belt binaries. The most tantalizing question, whether Eris' internal heat could sustain a subsurface ocean like Pluto's. While its surface temperature hovers near -400 degrees Fahrenheit, the right mix of salts and radioactive elements might keep pockets of liquid water trapped beneath miles of ice. Dysnomia's subtle gravitational nudges could even help stir that hidden sea, preventing it from freezing solid. Of course, this is speculation, but that's the thrill of the Kuiper Belt. Every new discovery peels back another layer, revealing a solar system far stranger and more dynamic than we ever imagined. What's certain is that Eris and Dysnomia aren't just frozen relics. They're a dynamic duo challenging our assumptions about what's possible in the outer darkness and proof that even the smallest moons can hold the keys to the biggest mysteries. Makemake might be Pluto's lesser-known cousin, but this icy world is anything but ordinary. Named after the creation deity of the Rapa Nui people, it's a frozen enigma that defies expectations at every turn. Imagine a world nearly as large as Pluto, yet so starkly different, a place where the sky isn't just empty but missing. Unlike Pluto's hazy, dynamic atmosphere, Makemake's surface is exposed to the void with no detectable blanket of gas to soften the harshness of space. That absence is a puzzle. Given its size and composition, scientists fully expected to find at least a whisper of an atmosphere here. But when telescopes trained their gaze on Makemake during a stellar occultation, a moment when it passed in front of a distant star, there was no telltale flicker of atmospheric distortion. Just the cold, hard reality of a world frozen in silence. What Makemake lacks in air, it makes up for in sheer brilliance. Its surface is one of the brightest in the Kuiper Belt, reflecting sunlight like a cosmic mirror. That gleam comes from a thick coating of methane ice spread across the terrain in strange, patchy deposits. Some areas glisten with fresh frost, while others resemble tar-stained snow, darkened by eons of radiation baking the surface into complex organic compounds. The contrast creates a surreal, mottled landscape, as if some celestial painter got distracted mid-stroke. Even more intriguing, the methane isn't just lying there, it's vanishing. Sunlight, feeble as it is at this distance, slowly transforms the ice directly into gas, a process so delicate it leaves no trace behind. Unlike Pluto, where gases linger to form an atmosphere, Makemake's feeble gravity can't hold onto them. They simply escape, lost to the void. Then there's the shocker, a tiny moon hidden in Makemake's glare for over a decade. Dubbed MK2, this diminutive companion was only spotted in 2016, lurking so close to its parent world that it was like finding a needle in a cosmic haystack. MK2 discovery was a masterclass in persistence. Astronomers had to comb through Hubble data with painstaking precision to tease its faint signal from Makemake's overwhelming brightness. The moon's existence rewrote the rules. Before MK2, Makemake was the only large Kuiper Belt object without a known satellite. Now, it's clear that even the most unlikely worlds can have hidden partners. MK2's dark surface raises even more questions. While Makemake shines like a beacon, its moon is pitch black, reflecting less than 4% of the sunlight that hits it. One theory suggests MK2 might be a captured fragment from a collision. Its original ice is long since vaporized. Another posits that Makemake's weak gravity allows solar radiation to bake its moon's surface into a charcoal-like crust, stripping away volatile materials over billions of years. Whatever the explanation, the pair's stark contrast highlights the Kuiper Belt's astonishing diversity, a reminder that no two objects out here play by the same rules. Makemake's story isn't just about absence, it's about defiance. A world this large should have an atmosphere. A moon this dark shouldn't orbit something so bright. Yet here they are, challenging our models at every turn. If the Kuiper Belt teaches us anything, it's that the universe thrives on exceptions, and Makemake, with its glittering silence and shadowy companion, might just be the most compelling exception of all. Haumea isn't just another dwarf planet, it's a cosmic oddity spinning so fast, it's been stretched into the shape of a football. Imagine a world where the days blur past in just under 4 hours, hurtling through its rotation with such ferocity that its equator bulges outward, defying the usual spherical calm of most planets. This bizarre shape isn't just a curiosity, it's a clue to Haumea's violent past, a story written in the scars of its surface and the peculiar entourage that orbits it. What really sets Haumea apart, though, is its ring, a thin, delicate halo of debris circling its waist like a celestial belt. Until its discovery in 2017, rings were thought to be the domain of gas giants like Saturn. Finding one around a tiny, icy world was like stumbling upon a hummingbird pulling a freight train. This ring isn't just for show. It's a relic of chaos, likely formed from the shattered remains of a colossal collision billions of years ago. The fragments trapped in Haumea's gravitational grip now glide in silent formation, a ghostly reminder of the violence that shaped this family of objects. Speaking of family, Haumea doesn't travel alone. Two moons, Haumea and Makemake, whirl around it in a dynamic dance. Haumea, the larger of the pair, is nearly round and coated in crystalline water ice, so pristine it sparkles like shattered glass under distant sunlight. Namaka, on the other hand, is smaller and more irregular, its orbit so eccentric that it loops unpredictably around its parent. Together, they tell a story of destruction and rebirth, a tale of a catastrophic impact that likely birthed not just these moons, but an entire clan of icy fragments now scattered across the Kuiper Belt. Scientists call this the Haumea family, a group of over a dozen objects with nearly identical compositions and orbits, all tracing their lineage back to a single shattering event. Picture a cosmic billiard shot, a rogue object perhaps as large as Pluto itself, slamming into Haumea with enough force to splinter it, spin it up, and send shards flying into the void. The debris left behind eventually settled into the moons and ring we see today, while the rest drifted away, becoming their own frozen nomads. Yet the strangest part: Haumea's surface, while most Kuiper Belt objects are dull and dark, this dwarf planet gleams with fresh, bright ice, as if it's constantly renewing itself. Some researchers think cryovolcanoes might be at work, spewing slushy water from deep within, while others argue that Haumea's rapid rotation flings volatile ices to its surface, where they freeze into a gleaming veneer. Either way, it's a world caught between destruction and renewal, a spinning top balanced on the edge of cosmic chaos. Haumea's existence forces us to rethink what's possible in the outer solar system. A football-shaped world with rings, moons, and a scattered family. It's proof that even in the frozen dark, violence and beauty can coexist, and that the universe has a flair for the dramatic we're only beginning to understand. Quaoar might not be a household name, but this distant world is quietly rewriting the textbooks on how planetary rings behave. About half the size of Pluto, it's one of the Kuiper Belt's most substantial residents, yet its real claim to fame lies in something far stranger. A ring system orbiting so far away, it defies every known rule of celestial mechanics. Picture a hula hoop floating in space, but instead of hugging close to its planet like Saturn's iconic rings, this one spins way out in the cosmic suburbs, over 7 times farther than the supposed maximum distance for stable rings. It's like finding a campfire still burning a mile from its woodpile, utterly inexplicable with current science. This ring sits far beyond Quaoar's Roche limit, the theoretical boundary where tidal forces should prevent ring material from coalescing. Inside this limit, gravity tears apart loose debris, creating the familiar dusty halos we see around Saturn or Uranus. Outside, material should clump together, forming moons. Yet Quaoar's ring persists in this no-man's land, pristine and unchanging, as if some unseen hand is holding it in place. Scientists are scrambling for explanations. Some suggest invisible shepherd moons might be corralling the debris, their gravity sculpting the ring into order. Others propose exotic physics, like electrostatic forces or collisions so rare that the ring particles simply haven't had time to clump together yet. The wildest theory, Quaoar's ring could be a fleeting snapshot of a moon's birth or death, caught in the act over astronomical timescales. Then there's the ring's odd composition. While most rings are icy or rocky, Quaoar's appears densely packed with complex organic compounds, giving it an unusually dark hue. This suggests it might be made of primordial material, unchanged since the solar system's infancy, a frozen relic of the chaos that once reigned here. Even more perplexing, the ring isn't perfectly circular. Its uneven shape hints at disturbances, possibly from Quaoar's small moon Weywot, whose gravity might be tugging at the debris in ways we don't yet understand. What makes Quaoar's defiance so thrilling is what it implies about the rest of the Kuiper Belt. If rings can exist where they shouldn't, what other impossible features might be hiding in the darkness? Every anomaly like this forces us to reconsider the forces shaping these distant worlds, not just gravity, but hidden actors like magnetism, radiation, or even subtle pushes from the solar wind. Quaoar's rebellious ring isn't just a curiosity, it's a beacon illuminating how much we still have to learn about the silent, frozen fringes of our solar system. Weywot may be Quaoar's only known moon, but this tiny companion is anything but obedient. Circling its parent world like a rebellious dancer, it follows an orbit so erratic that it defies the neat, circular paths moons typically obey. Instead, Weywot traces a lopsided ellipse, swinging close to Quaoar before veering far out into the void, a pattern suggesting this little moon has endured a turbulent past. The key to unlocking its chaotic motion lies in gravity. Most moons form from the debris of ancient collisions, settling into stable orbits over time. But Weywot's jagged path implies something more violent, a cataclysmic encounter that sent it tumbling. One theory suggests Quaoar itself suffered a colossal impact, ejecting material that eventually coalesced into Weywot, but left the moon with a gravitational memory of that explosive birth. Another possibility, a close brush with another massive Kuiper Belt object could have yanked Weywot off course like a cosmic game of pinball. The moon's irregular orbit also raises questions about Quaoar's unseen history. For Weywot to maintain such an eccentric path, Quaoar's gravitational field must be uneven, perhaps due to hidden mass concentrations beneath its icy crust. Imagine a world with dense, rocky pockets lurking under its surface, tugging at its moon like invisible strings. Alternatively, Quaoar might have once had other moons, their gravitational jostling leaving Weywot permanently unsettled. Then there's the mystery of Weywot's composition. While Quaoar's surface is coated in crystalline water ice, Weywot appears darker, its surface likely stripped of volatiles by eons of radiation. That stark contrast hints it might be a captured object, a wanderer snared by Quaoar's gravity rather than a sibling born from the same collision. If true, it would mean Quaoar's system is a patchwork family, part homegrown, part adopted. Weywot's greatest significance, though, might be what it reveals about Quaoar's ring. Their gravitational interplay could explain why the ring remains intact at such an impossible distance. Some models suggest Weywot's tugs might prevent ring particles from clumping into new moons, acting as a celestial shepherd keeping the debris in line. Or perhaps the moon's chaotic orbit stirs the ring, creating density waves that stabilize it. Either way, this tiny moon is proof that even the smallest objects can shape their surroundings in profound ways, turning Quaoar's quiet corner of the Kuiper Belt into a theater of celestial chaos. Sedna isn't just another icy wanderer, it's a cosmic renegade, drifting so far from the sun that its orbit feels almost mythical. Picture a lonely world taking 11,400 years to complete a single trip around our star, a path so stretched that at its farthest, it ventures over 900 times Earth's distance from the sun. This isn't just an outlier. Sedna is one of the most detached objects ever discovered, a rebel that refuses to play by the Kuiper Belt's rules. Its existence raises a tantalizing question: how did something end up so startlingly isolated? The most striking clue lies in Sedna's color, a deep, rusty red, darker than even Mars. That hue suggests a surface coated in complex organic molecules, baked by eons of cosmic radiation into a thick, tar-like sludge. But here's the twist: Sedna's redness isn't uniform. Patches of brighter material peek through, hinting at recent resurfacing events. Some scientists speculate cryovulcanic eruptions might be at work, blasting fresh ice from hidden reservoirs below. Others think seasonal shifts could be exposing buried layers as Sedna's elongated orbit brings it slightly closer to the sun, triggering sublimation. Then there's the jaw-dropper: Sedna might hide an ocean. Despite surface temperatures near -400 degrees Fahrenheit, the tug of an unseen moon, or the lingering heat of radioactive decay, could keep slushy water trapped beneath its icy shell. If true, Sedna joins an exclusive club of worlds like Europa and Enceladus, places where liquid water persists against all odds. The kicker: Sedna's extreme distance means any ocean wouldn't rely on solar warmth at all. Instead, internal forces, tidal flexing or chemical reactions, might sustain it, proving habitability can exist even in the solar system's frozen hinterlands. But Sedna's true mystery is its origin. How did it end up in this bizarre, looping orbit? One theory suggests it was yanked from the Weywot cloud, that distant shell of icy leftovers surrounding the solar system, by a passing star in our sun's infancy. Another possibility, the gravitational hand of an unseen planet lurking even further out could have hurled Sedna into exile. This hypothetical Planet 9, if real, might explain not just Sedna's path, but the peculiar orbits of several other detached objects. Sedna's isolation makes it a time capsule. Unlike Kuiper Belt objects stirred by Neptune's gravity, Sedna's orbit has likely remained pristine, untouched since the solar system's birth. Studying it is like cracking open a freezer from 4.5 billion years ago, preserving secrets about how planetary systems form and how chaos can leave some worlds forever adrift. Yet for all its strangeness, Sedna might not be alone. Astronomers suspect an entire population of similar, detached objects could be lurking in the darkness, each with its own story of exile. If so, this Crimson Wanderer is just the first chapter in a much larger tale, one that could rewrite our understanding of the solar system's outer limits. Orcus lurks in the shadows of the Kuiper Belt like Pluto's eerie twin, a world so similar in size and orbit, yet twisted into a dark reflection of its more famous cousin. Nicknamed the anti-Pluto, it mirrors Pluto's dance with Neptune but with a sinister twist. While Pluto's resonance keeps it safely distant from the ice giant's gravity, Orcus's orbit locks it into a perfect cosmic counterbalance. Every time Pluto swings closer to the Sun, Orcus moves away, as if the two are connected by some invisible celestial seesaw. This bizarre synchronization isn't coincidence, it's a gravitational pass-to-due orchestrated by Neptune over billions of years, turning Orcus into Pluto's orbital shadow. But Orcus isn't just a carbon copy. Its surface tells a far darker story. Where Pluto gleams with reflective planes of nitrogen and methane, Orcus wears a cloak of dull, charcoal-gray ice pockmarked by ancient scars. This isn't mere dirt, it's likely tholins, the same complex organic gunk that stains Arrokoth and other distant worlds, baked into existence by eons of radiation. Yet even here there's intrigue. Recent thermal measurements hint at surprising warmth in patches, as if something beneath the ice is fighting the deep freeze. Could cryovolcanoes be at work, oozing sludgy mixtures of water and ammonia to freshen the surface? Or is Orcus's interior still churning with residual heat, flexing its frozen shell like a slow-motion lava lamp? Enter Vanth, Orcus's enigmatic moon. Unlike Pluto's Charon, a massive partner that creates a binary dance, Vanth is small but mighty, its dark surface etched with mysteries. What makes it extraordinary isn't just its size, but its speed. Vanth whips around Orcus in just 9.5 days, an orbital sprint that suggests it formed from a violent collision, much like Earth's moon. But here's the puzzle. Vanth's surface is even darker than Orcus's, absorbing nearly all the sunlight that touches it. Some scientists speculate it might be coated in primordial carbon, a relic from the solar system's birth, while others think relentless radiation has cooked its ices into a tar-like crust. The most tantalizing possibility, Vanth's orbit is decaying. Over millennia, tidal forces could be dragging it closer to Orcus, inching it toward a fate where it either crashes into its parent or shatters into a ring. If true, we might be witnessing the slow-motion death of a moon, a process usually reserved for gas giants, not icy dwarfs. This fragility underscores the Kuiper Belt's dynamism. Even here, in the frozen quiet, worlds and their companions are locked in gravitational dramas that reshape their destinies. Orcus and Vanth aren't just Pluto's doppelgangers, they're proof that the outer solar system thrives on contrasts. Where Pluto is vibrant and geologically alive, Orcus is a silent sentinel of the dark, its moon a whisper of impending change. Together, they force us to confront how little we truly understand about these distant realms where every twin has a twist, and every shadow holds secrets waiting to be uncovered. Gong Gong moves through the Kuiper Belt like a drowsy giant, its rotation so sluggish that a single day stretches across 3 Earth weeks. This isn't just another icy relic, it's a world painted in deep crimson, one of the reddest objects ever spotted in the outer solar system. That striking hue isn't random. It's the signature of complex organic molecules called tholins, forged over eons by radiation bombarding its surface. But Gong Gong's true drama lies in its orbit, a lopsided, erratic path that swings it between 19 and 67 times Earth's distance from the Sun. Unlike the predictable loops of most planets, Gong Gong's trajectory feels almost rebellious, as if it's resisting the gravitational rules that govern its neighbors. What makes Gong Gong truly fascinating is its water. Spectroscopic observations reveal vast expanses of water ice blanketing its surface, some so pure it gleams like polished glass under distant sunlight. Yet this ice isn't static, it's locked in a delicate dance with the void. When Gong Gong nears the Sun during its elongated orbit, temperatures rise just enough barely to allow traces of its frozen volatiles to vaporize. For a fleeting moment, this distant world might puff out a wispy, temporary atmosphere, a ghostly shroud of nitrogen or methane gas clinging to its surface. It's a phenomenon scientists call atmospheric venting, and on Gong Gong it could unfold in slow motion with gases lingering for years before freezing back into the ice. The real shocker, Gong Gong's moon, Xiangliu. This small, dark companion orbits chaotically, its path tilted and irregular, much like its parent spin. Xiangliu's presence raises tantalizing questions. Was it captured during a close encounter, or is it a fragment from a cataclysmic collision that also set Gong Gong's slow rotation in motion? The moon's gravity might even play a role in destabilizing Gong Gong's already messy orbit, tugging it further into eccentricity over millennia. Then there's the enigma of Gong Gong's brightness. Despite its vast distance, it reflects more light than expected for an object its size, suggesting its surface is constantly refreshed. Could cryovolcanism be at work, with plumes of slushy water erupting from below? Or does its sluggish rotation allow frost to migrate across the surface, redistributing ice in a slow motion cycle? Either scenario hints at hidden activity beneath Gong Gong's frozen crust, a reminder that even in the Kuiper Belt's deep freeze, worlds refuse to sit still. Gong Gong stands as a testament to the solar system's untamed diversity, a slow-spinning, red-stained wanderer with a moon that defies order and ice that breathes when the cosmos allows it. If there's one lesson this distant world teaches us, it's that the outer reaches are anything but quiet. They're a stage for silent, stubborn defiance, where every orbit tells a story of chaos barely held in check. Ixion stands out in the Kuiper Belt like a smoldering ember against coal, a world glowing with a reddish tint that defies its frozen surroundings. Named after the mythological king condemned to an eternally burning wheel, this Plutino, a class of objects locked in orbital resonance with Neptune, holds secrets beneath its ruddy surface that challenge our understanding of chemistry in the deep freeze. While most similarly sized Kuiper Belt objects wear drab, grayish coats of ancient ice and rock, Ixion's distinct hue suggests something far more complex is at play. The source of that rusty color, likely tholins, the same organic gunk staining other distant worlds like Arrokoth and Pluto. But here's the twist: Ixion's tholins appear unusually rich, hinting at a surface chemistry more elaborate than its neighbors. Radiation from the Sun, even at this staggering distance, has been cooking methane and nitrogen ices into these dark, complex compounds over billions of years. Yet the puzzle is why Ixion's surface evolved this way when other Plutinos of comparable size and distance remained comparatively bland. One theory points to its orbit, a looping, occasionally sunward path that might allow fleeting moments of sublimation, exposing fresh ice to cosmic rays and sparking more intense chemical reactions. Another possibility, Ixion could harbor internal heat sources like leftover radioactivity or residual energy from its formation, subtly altering its surface chemistry over eons. Even more intriguing are the whispers of crystalline water ice spotted in spectral data. Unlike the amorphous ice expected in the Kuiper Belt's perpetual cold, these structured ice signatures suggest brief periods of warming, enough to reorganize molecules into more orderly arrangements. Could Ixion have experienced tidal heating from ancient encounters, or does its spin generate just enough friction to soften its icy shell? Either scenario would make it a rare exception in a region where most worlds are thought to be geologically dead. Then there's the lingering question of atmosphere. While too small to hold gases permanently, Ixion's occasional proximity to the Sun might allow temporary bursts of sublimated nitrogen or methane, creating a transient, ghostly shroud. If so, it would place Ixion in an elite club of Kuiper Belt objects that briefly breathe, cycling between frozen silence and fleeting activity. What truly sets Ixion apart, though, is its defiance of expectations. In a belt where objects are supposed to be uniform relics, this crimson wanderer stands as proof that chemistry in the outer solar system is far from settled. Every anomaly on its surface is a clue, not just about Ixion's past, but about the invisible forces shaping all the icy worlds lurking in the darkness. If something as unassuming as a moderately red Plutino can upend assumptions, what other surprises might be hiding in plain sight? Varuna spins like a cosmic top, whirling so fast it's been stretched into the shape of an overinflated football, completing a full rotation in just under 6 hours. To put that into perspective, if Earth spun that quickly, our days would blur past in a dizzying rush, and the planet itself would bulge violently at the equator. Yet here's Varuna, a mid-sized Kuiper Belt object roughly half the diameter of Pluto, defying gravity's pull to maintain this bizarre, elongated form. What's even more surprising, it hasn't shattered under the strain. Most objects rotating this quickly would fling themselves apart, but Varuna clings together, its icy structure just flexible enough to withstand the chaos. The secret to its survival might lie in its composition, a mix of water ice, rock, and a tar-like coating of complex organic molecules. Unlike the gleaming surfaces of Makemake or Pluto, Varuna's exterior is eerily dark, reflecting only a fraction of the sunlight that touches it. That darkness isn't just dirt, it's likely tholins, the same radiation-baked sludge found on other distant worlds, but here it's spread thick like a cosmic stain. This raises a tantalizing question. Why is Varuna so much darker than similarly sized Kuiper Belt neighbors? One theory suggests it might be the shattered core of a once larger body. Imagine an ancient world, perhaps even Pluto-sized, that suffered a catastrophic collision early in the solar system's history. The impact could have stripped away its brighter outer layers of volatile ices, methane, nitrogen, leaving behind a stripped-down, rocky, icy remnant spinning wildly from the violence of the encounter. Varuna's dark surface, then, would be the scar tissue of that primordial disaster, its rapid rotation a ghostly echo of the collision that birthed it. Supporting this idea are subtle spectral hints of crystalline water ice lurking beneath the murky exterior. Unlike the disorganized ice expected in the Kuiper Belt's perpetual cold, these structured molecules suggest Varuna experienced brief periods of warming, possibly from the heat of that ancient impact or from internal radioactive decay. If true, it would mean this misshapen world isn't just a frozen relic. It's a survivor carrying the wounds of a violent past while clinging to traces of its original chemistry. But the most compelling clue to Varuna's origins might lie in its family, or lack thereof. Most collision survivors in the Kuiper Belt, like Haumea, are surrounded by a swarm of smaller fragments, debris from the same catastrophic event. Varuna, though, drifts alone. Does this mean its siblings were ejected into the darkness, or is it an orphan from a long-vanished parent body? Either way, its isolation makes it a rare window into the chaos of the early solar system, a time when giant impacts were the rule, not the exception. Varuna's existence forces us to rethink how objects in the Kuiper Belt evolve. Not all of them are pristine time capsules. Some are battered survivors, reshaped by violence and stripped to their cores. And if something as peculiar as Varuna, dark, fast-spinning, and strangely resilient, could emerge from that ancient carnage, what other shattered remnants might still be lurking in the shadows, waiting to be found? 2002 MS4 should be anything but lonely, a mid-sized Kuiper Belt object nearly 500 miles across, large enough to have its own entourage of moons like many of its peers. Yet when astronomers scour its surroundings, they find nothing but empty space, no faint glimmers of orbiting companions, no dusty rings, just silence. This absence makes 2002 MS4 an outlier in a region where even smaller objects often travel with moons in tow. The question isn't just why it lacks satellites, it's what this solitude reveals about the hidden rules governing these distant worlds. Then there's the puzzle of its spin. Like Varuna, 2002 MS4 rotates unusually fast, completing a full turn every 6.5 hours. But where Varuna's rapid whirl distorts it into a football shape, 2002 MS4 shows only subtle variations in brightness, what scientists call a light curve. These gentle fluctuations suggest it's nearly spherical, its gravity strong enough to resist the dramatic bulging seen in smaller, faster-spinning objects. That near-perfect roundness hints at a dense interior, perhaps a rocky core wrapped in a thick mantle of ice. But here's the catch: such a structure should have formed moons during its early, violent history. The fact that it didn't imply something unusual happened, either a collision stripped them away, or its formation process was peculiarly quiet. The most tantalizing clue comes from its surface. Unlike the dark, tholin-stained terrains of many Kuiper Belt objects, 2002 MS4 reflects sunlight with surprising efficiency, its icy exterior relatively untouched by radiation's darkening effects. Some researchers speculate this brightness could mean active resurfacing cryovolcanic plumes or geysers belching fresh ice onto the surface, erasing older, darker patches. If true, it would place this seemingly inert world in the company of dynamic bodies like Pluto and Haumea, where hidden energy reshapes the landscape. Yet without moons to drive tidal heating, what could power such activity? The answer might lie in its chemistry. 2002 MS4 spectrum reveals traces of ammonia hydrates mixed with water ice, a volatile combination that lowers the freezing point of subsurface slush. Even a whisper of internal heat, perhaps from radioactive decay, could keep these mixtures oozing to the surface in slow-motion eruptions. What makes 2002 MS4 so compelling isn't just what we see, but what we don't. Its moonless existence challenges the assumption that all sizable Kuiper Belt objects form or capture satellites. Its undisturbed shape defies expectations for fast rotators. And its gleaming surface whispers of unseen forces at work, proving that even in the quietest corners of the solar system, worlds find ways to surprise us. Sometimes absence speaks louder than any discovery, and 2002 MS4's silence is deafening. Salacia and its moon Actaea don't just orbit each other, they perform a slow, stately waltz in the outer darkness, locked in a gravitational embrace that reveals secrets about their hidden interiors. This binary system, discovered in 2004, stands out even among the Kuiper Belt's oddities. Salacia itself is sizable, stretching about 550 miles across, but it's Actaea that steals the show, a moon nearly 250 miles wide, making it one of the largest known companions relative to its parent in the region. Their dance is leisurely, taking almost 5.5 days to complete a single loop, a stark contrast to the frantic spins of worlds like Haumea. What makes this pairing extraordinary isn't just their size, but what their orbital tango tells us. By calculating the subtle wobbles in their movements, astronomers deduced Salacia's density, and the numbers were shocking. This world is far lighter than expected, with a density barely higher than water ice. That means it can't be a solid ball of rock and ice like Pluto or Eris. Instead, Salacia likely has a porous, rubble pile interior, a loosely packed jumble of icy fragments with cavernous gaps between them. Picture a cosmic snowball, gently compressed but still riddled with voids, a fragile relic from the solar system's violent infancy, when collisions were frequent but impacts weren't always destructive enough to fuse debris into something denser. Actaea's role in this story is just as intriguing. The moon's nearly circular orbit suggests it formed from the same ancient collision that might have given Salacia its fluffy structure. Imagine a colossal smash-up billions of years ago, scattering debris that slowly coalesced into this odd couple, with Actaea emerging as the largest surviving fragment. But here's the twist: Actaea's surface is markedly darker than Salacia's, absorbing almost all sunlight that touches it. This stark contrast hints at divergent histories. Perhaps Salacia's gravity attracted brighter ices over time, while Actaea, smaller and weaker, couldn't hold onto them, leaving its surface exposed to radiation's darkening effects. The real marvel, though, is how this system defies expectations. Binary objects aren't rare in the Kuiper Belt, but pairs this large with such a pronounced density difference are exceptional. Salacia's featherweight composition suggests that not all mid-sized Kuiper Belt objects are built alike. Some might be rubble piles, barely holding themselves together, while others, like Pluto, are dense enough to have undergone geological differentiation, with heavy elements sunk to their cores. This variability forces us to reconsider how these distant worlds evolved. Did Salacia avoid the heating that compacted others? Or was it always destined to remain a fragile whisper of the past, its gaps and hollows preserving a record of the gentle accretion that built the solar system's outermost worlds? One thing's certain: Salacia and Actaea aren't just passive fossils. Their delicate dance, their mismatched surfaces, and Salacia's improbable lightness are all clues, whispers from an era when the Kuiper Belt was a construction site, not a graveyard. Every wobble, every shadow, every spectral hint they offer pulls back another layer of mystery, revealing just how chaotic and how creative the birth of our solar system truly was. Varda and its moon, Ilmarë, don't follow the usual script. They're a cosmic odd couple drifting so far apart. They stretch the limits of what we thought possible for a binary system in the Kuiper Belt. Most paired objects out here, like Pluto and Charon, orbit snugly, their gravitational embrace tight enough to fit comfortably within the span of a planet. But Varda and Ilmarë, they're separated by a staggering 4,500 miles, nearly twice the distance between Earth and the Moon. If you stood on Varda's surface, its moon would appear as little more than a faint speck in the sky, a dim companion barely clinging to its gravitational tether. This vast separation isn't just a curiosity, it's a clue. In the Kuiper Belt, where collisions and captures shape most binary systems, such a wide orbit should be unstable. Over time, the tug of passing objects or the sun's gravity should have pried them apart, yet here they are, locked in their slow, distant dance. One explanation: Varda might be hiding unseen mass, perhaps a dense core or a ring of debris acting as a gravitational anchor to keep Ilmarë from drifting away. Alternatively, Ilmarë itself could be far more massive than it appears, its gravity subtly reinforcing the bond between them. Then there's the mystery of their past. Orbits this wide usually form in one of two ways: a gentle capture, where two independent objects gradually fell into mutual orbit, or a violent collision that sent a moon spiraling outward. If it was a capture, Varda and Ilmarë must have encountered each other at just the right speed and angle, a cosmic fluke. But if it was a collision, the energy of that impact had to be exquisitely balanced, enough to send Ilmarë flying outward without completely severing the connection. Either scenario makes this pair a statistical anomaly, a rare survivor of orbital chaos. Ilmarë's path holds even more intrigue. Unlike the neat, circular orbits of most moons, its trajectory is slightly elliptical, as if something once yanked it off course. Could an unseen third object have disrupted the system, scattering Ilmarë into this lopsided loop? Or does Varda's irregular shape, potentially lumpy from a history of impacts, create uneven gravitational tugs that distort the moon's motion? Every wobble in Ilmarë's orbit is a breadcrumb leading back to the forces that sculpted this estranged duo. What makes Varda and Ilmarë truly remarkable is how they force us to rethink the limits of binary survival. If a system this tenuous can endure billions of years in the Kuiper Belt's gravitational minefield, then our models of stability might need revision. Perhaps other widely separated pairs are hiding in the darkness, their fragile bonds whispering secrets about the delicate balance between attachment and escape. In a region where most objects cluster close, Varda and Ilmarë stand apart, both literally and figuratively proving that even in the coldest reaches of space, relationships take on forms we're only beginning to understand. Chaos doesn't look like it belongs in the Kuiper Belt at all. While most objects in this frozen realm glint with water ice or wear coats of reddish tholins, chaos stands out for its eerie neutrality, a dull, grayish hue that makes it fade into the cosmic background like a shadow. Even more baffling, spectroscopic studies reveal virtually no trace of water ice on its surface, a glaring omission in a region where frozen water is as common as sand on a beach. This anomaly raises a radical possibility. What if chaos isn't a native of the outer solar system, but a refugee from somewhere much closer to the sun? Theories about its origin read like a cosmic detective story. One hypothesis suggests chaos could be a rogue fragment of the asteroid belt, hurled outward by Jupiter's immense gravity during the solar system's chaotic infancy. Imagine a wandering piece of Vesta or Ceres, rich in silicates but devoid of the volatile ices that dominate the Kuiper Belt, banished to the deep freeze by a gravitational slingshot. Supporting this idea is chaos's spectral signature, which matches certain inner belt asteroids far more closely than its icy neighbors. Yet there's another, even wilder possibility. Chaos might be a survivor from the long-vanished population of primordial objects that once orbited near the giant planets, a relic from a time before Neptune and Uranus migrated outward, scattering debris in their wake. These ancient bodies, if they existed, would have formed under different conditions than the Kuiper Belt's icy denizens, explaining chaos's stark contrast. The absence of water ice could mean it never accumulated the same frozen volatiles, or that solar heating stripped them away before its exile. What's undeniable is chaos's defiance of expectations. Its orbit, while typical for a Kuiper Belt object, feels like a cosmic disguise, a neutral mask hiding a tumultuous past. Without the usual icy reflectivity, it absorbs sunlight like a sponge, making it one of the darkest known objects in the region. This darkness isn't just skin deep. It hints at a composition fundamentally alien to its surroundings, as if chaos wandered into the wrong neighborhood and stayed. The most tantalizing clue lies in what's missing. Most Kuiper Belt objects bear scars from collisions or radiation, their surfaces altered over eons. Chaos, though, shows little evidence of such weathering. Is its surface younger, refreshed by some unknown process, or is its material simply tougher, resistant to the forces that sculpt its icy counterparts? Every answer only deepens the mystery, painting chaos as a cosmic outlier, a silent witness to the solar system's turbulent youth, carrying secrets we've only begun to unravel. Deucalion doesn't just hide in the Kuiper Belt, it vanishes. While most objects in this distant region reflect at least a sliver of sunlight, Deucalion's surface absorbs nearly all of it, making it darker than fresh asphalt, darker even than coal. This isn't just a quirk of shadow. This world is one of the blackest natural objects ever discovered in our solar system, a void dressed as a celestial body. But that profound darkness isn't empty, it's teeming with clues about the primordial chemistry that birthed our cosmic neighborhood. The secret lies in what's coating Deucalion's surface, a thick, sticky layer of organic compounds unlike anything found on inner planets or even most Kuiper Belt objects. These aren't simple ices or rocky minerals, but complex carbon-based molecules, the kind that could have been the precursors to life under different circumstances. Radiation from the Sun, feeble as it is at this distance, has been bombarding Deucalion for billions of years, slowly cooking its ices into a tar-like sludge of tholins, the same reddish-brown gunk seen on Pluto and Titan, but here concentrated to an extreme. Imagine a world painted with the cosmic equivalent of crude oil, its surface so chemically altered by time that it barely resembles the frozen volatiles it began with. What's startling isn't just how dark Deucalion is, but why. Most Kuiper Belt objects mix their organics with reflective water ice, creating a mottled appearance. Deucalion, by contrast, seems to have either lost its ice entirely or buried it under an overwhelming blanket of these light-absorbing compounds. One theory suggests it might have formed in a particularly carbon-rich pocket of the early solar system, where complex molecules were more abundant than water. Another possibility, Deucalion could be a fragment of a much larger body that was stripped of its brighter outer layers by a catastrophic collision, leaving behind a naked core of primordial gunk. The implications ripple far beyond this one strange world. If Deucalion's extreme darkness is a product of its unique chemistry, then the Kuiper Belt must have been a patchwork of varying conditions from the very beginning. Some areas rich in water, others dominated by organics, each preserving a different recipe from the solar system's construction. This wasn't a uniform deep freeze, it was a sprawling cosmic laboratory, with each object its own experiment in chemical evolution. Even more tantalizing is what Deucalion might tell us about life's ingredients elsewhere. The same processes that blackened its surface could have been happening on countless other icy worlds, transforming simple molecules into increasingly complex ones. While Deucalion itself is far too cold and distant to host life, its existence proves that the building blocks of biology can emerge even in the most hostile corners of space. The real mystery, we don't know how many others like it are out there. Deucalion's darkness makes it incredibly hard to spot, a shadow among shadows. If it wasn't for the faintest wobble in its orbit, betrayed by the gravity of some unseen companion, we might never have noticed it at all. That raises a thrilling possibility. The Kuiper Belt could be littered with similar carbon-heavy worlds, each a silent monument to the diversity of creation, and a reminder of how much we still have left to discover. 2008 OG-19 doesn't just drift through the Kuiper Belt, it tumbles. Unlike the stately spheres of Pluto or Eris, this enigmatic world is likely stretched into an elongated shape, like a cosmic cigar spinning end over end through the void. The clues lie in its light curve, the subtle changes in brightness as it rotates. While most spherical objects show gentle fluctuations, 2008 OG-19's variations are extreme, hinting at a form so uneven, its reflective surfaces catch sunlight at dramatically different angles. Imagine a skyscraper tumbling through space, its glass windows flashing light erratically as they turn toward and away from the sun. That's the kind of chaotic dance this object might be performing, completing each rotation in just a few frantic hours. What could warp a world like this? The answer lies in speed. Rapid rotation can distort even massive objects, counteracting gravity's pull toward spherical perfection. Haumea, another Kuiper Belt oddball, spins so fast it's flattened into a football shape. But 2008 OG-19 might be spinning even faster, so fast that it's barely holding itself together. Some models suggest it could be near the critical limit where centrifugal force would rip it apart entirely, a fragile relic balancing on the edge of stability. The real surprise, its surface tells a different story from its shape. While most fast-spinning Kuiper Belt objects like Varuna are coated in dark, radiation-baked tholins, 2008 OG-19 gleams with an unexpected brightness. Spectral data reveals a surface dominated by relatively freshwater ice, untouched by the reddish stains common elsewhere. This contradiction, a twisted, high-speed rotator with a strangely pristine exterior, raises tantalizing questions. Could cryovolcanic activity be replenishing its ice, erupting slushy plumes that refreeze into a gleaming coat? Or does its elongated shape shield certain regions from radiation, preserving bright patches in perpetual shadow? Then there's the puzzle of its origin. Most irregularly shaped Kuiper Belt objects owe their forms to violent collisions, but 2008 OG-19's composition doesn't quite fit that narrative. Its ice is too pure, too uniform. An alternative theory suggests it might be a contact binary, two smaller bodies that gently merged long ago, their union leaving behind a stretched, dumbbell-shaped remnant. If true, its rapid spin could be a relic of that ancient embrace, the angular momentum of their dance preserved over billions of years. The more we study objects like 2008 OG-19, the clearer it becomes. The Kuiper Belt isn't just a museum of frozen relics. It's a dynamic arena where physics plays out in ways we're only starting to grasp. A world spinning itself into a frenzy, yet wearing a face of unexpected serenity, is proof that even in the stillness of the outer dark, nothing is ever truly at rest. 2010 KZ-39 doesn't follow the crowd. It's the cosmic rebel of the Kuiper Belt, slicing through the solar system's orbital plane at a jaw-dropping 30-degree angle. Most objects in this distant realm stick to a flat, orderly disk, like marbles rolling around a plate, but not this one. Its steeply tilted path suggests a history far more chaotic than its icy neighbors, a past written in the scars of gravitational battles we can only reconstruct. One possibility, this rogue might not be a true Kuiper Belt native at all. Some astronomers suspect it could be a captured centaur, a refugee from the volatile population of icy bodies orbiting between Jupiter and Neptune. Centaurs are infamous for their unstable lives, often flung into new paths by the gas giant's gravity. If 2010 KZ-39 was once among them, a close encounter with Neptune could have hurled it outward, locking it into its current skewed orbit. The evidence lies in its surface. While most Kuiper Belt objects wear a uniform reddish tint from eons of radiation, 2010 KZ-39's color is a wild card, hinting at a different chemical history, one shaped by warmer temperatures and more intense solar exposure, hallmarks of an inner solar system upbringing. Yet there's another, darker explanation. It might be a survivor of celestial violence. The Kuiper Belt wasn't always the quiet graveyard it is today. Billions of years ago, as Neptune migrated outward, its gravity tore through the region like a wrecking ball, scattering objects into tilted and elongated orbits. 2010 KZ-39 could be one of those casualties, a world wrenched from its original path and left to wander this lopsided course. Its inclined orbit might be a fingerprint of that ancient upheaval, a silent witness to the solar system's turbulent youth. What makes this object so compelling isn't just its odd trajectory, it's the lingering uncertainty. Is it an outsider that fought its way in, or a local forever changed by cosmic chaos? The answer could reshape our understanding of how the Kuiper Belt's population formed. Every tilted orbit like this is a clue, a breadcrumb leading back to the forces that sculpted the outer solar system. And until we get a closer look, until a spacecraft catches this cosmic drifter in its lens, 2010 KZ-39 will remain a tantalizing question mark, a reminder that even in the quietest corners of space, rebellion wears many faces. 2014 UZ-224, affectionately nicknamed DD, wasn't spotted the usual way. It revealed itself through a ghostly whisper of heat in the void. While most Kuiper Belt objects are found by their faint reflected sunlight, astronomers at the Ulma telescope array caught DD's signature in an entirely different spectrum, the faint thermal glow of its own warmth. Imagine trying to find an ice cube by the heat it radiates in a freezer. That's the level of precision required to detect this distant wanderer. At the time of its discovery in 2016, DD was one of the most distant known objects in our solar system, orbiting roughly 92 times farther from the Sun than Earth. Yet despite that bone-chilling distance, it emitted just enough warmth for Ulma-sensitive instruments to pick up, marking a breakthrough in how we hunt for hidden worlds. But DD's true intrigue lies in its identity crisis. Stretching about 400 miles across, it flirts with the unofficial threshold for dwarf planet status, a label that depends not just on size, but on whether its gravity has sculpted it into a rounded shape. The catch: no one's gotten a clear enough look to confirm. What we do know is tantalizing. Its surface is likely coated in exotic ices like ethane and methane, and its rotation period, an unusually slow 25 hours, hints at possible asymmetries, as if it's wobbling through space like a lopsided top. Then there's the enigma of its orbit, a stretched, lopsided path that swings between 56 and 120 astronomical units from the Sun. This elliptical journey takes over 1,100 years to complete, making DD a cosmic nomad drifting between the Kuiper Belt's outskirts and the fringes of interstellar space. Such extreme orbits are rare, and they usually betray a history of gravitational trauma. One leading theory suggests DD might have been yanked from a more circular path by Neptune's migration billions of years ago, sent careening into the deep freeze like a billiard ball knocked off course. Yet the most compelling mystery is what DD represents, a possible missing link between known dwarf planets and the hypothetical planet 9. Its orbit aligns loosely with the cluster of trajectories that some scientists argue point to an undiscovered giant planet lurking beyond Neptune. If true, DD could be one of many objects nudged into odd paths by this unseen behemoth, a tracer bullet leading us deeper into the dark. For now, DD remains a paradox, too distant to study in detail, yet too intriguing to ignore. Its discovery by heat signature alone proves how much we've still left to learn about the solar system's shadowy frontiers. Whether it earns the dwarf planet title or stays classified as a large Kuiper Belt object, one thing's certain: DD is a reminder that even in the deepest cold, the cosmos hides stories written in warmth and motion. 2015 TG387, better known as the Goblin, isn't just another icy wanderer, it's a cosmic recluse, drifting so far from the Sun that its orbit feels almost fictional. At its closest, it still lingers twice as far as Pluto. At its most distant, it vanishes into the void, a staggering 2,300 times farther than Earth. This extreme path takes 40,000 years to complete, a timescale so vast human civilization has barely flickered into existence since the Goblin last swung through its perihelion. What makes this object so compelling isn't just its distance, it's the peculiar shape of its orbit. Like a handful of other extreme trans-Neptunian objects, the Goblin follows a stretched, clustered trajectory that seems to whisper of unseen forces. These paths align suspiciously, as if something massive, perhaps the elusive planet 9, is herding them like celestial sheep. The Goblin's orbit tilts sharply, too, a 32-degree skew that further hints at gravitational nudges from something lurking in the darkness. Then there's its color, a faint pinkish blush, a shade rarely seen in the Kuiper Belt's palette. This tint likely comes from tholins, the same complex organics that stain Pluto and Titan, but here they're baked by unimaginable patience. Radiation has had eons to work on the Goblin's surface, transforming simple ices into ruddy sludge without the disturbance of planetary encounters or collisions. The real enigma, its isolation. Most solar system objects share orbits with families or clusters, remnants of ancient collisions. The Goblin drifts alone, a frozen hermit with no known kin. This solitude suggests it might be a pristine relic of the solar system's infancy, untouched by the chaos that sculpted its neighbors. Or perhaps it was ripped from a larger body and flung into exile, its orbit stretched by a gravitational slingshot we can only theorize about. The goblin's existence forces us to confront how little we know about the solar system's outer fringes. If something this unusual, this defiantly odd, can hide in plain sight, what else might be waiting in the dark? Every parameter of its orbit, every spectral whisper from its surface, is a breadcrumb leading toward answers we're only beginning to grasp. And until we find them, the goblin remains a ghostly sentinel, tracing its lonely path through the abyss. 2021 DR15 doesn't just drift through the Kuiper Belt, it breathes. Unlike most of its sluggish, frozen neighbors, this enigmatic object follows a wild, looping path that mirrors the trajectory of comets, swinging close enough to the sun to potentially wake its dormant ices. What makes it truly baffling isn't just its orbit. It's the possibility that this might be one of the rare Kuiper Belt objects caught in the act of becoming something else entirely. Could it be an active comet in disguise, or a wanderer halfway to joining the Weywot cloud's icy swarm? The clues lie in its movement. 2021 DR15's orbit is stretched into a dramatic ellipse, carrying it from the Kuiper Belt's outer fringes to the realm of the giant planets, a path far more chaotic than the sedate circles of objects like Pluto or Haumea. This kind of instability usually signals a history of gravitational encounters, perhaps with Neptune or Uranus, which could have yanked it from a quieter orbit and sent it careening inward. But here's the twist. Telescopes have caught hints of faint outgassing whispers of volatile materials like carbon monoxide or nitrogen puffing from its surface. If confirmed, that would make it one of the first known active Kuiper Belt objects, a frozen world shaking off its slumber like a comet waking from hibernation. The implications are staggering. Most classical Kuiper Belt objects are too distant and cold for their ices to sublimate, locking their chemistry in deep freeze. But 2021 DR15's occasional forays into slightly warmer territory might trigger temporary outbursts, blurring the line between static iceball and dynamic comet. Some researchers speculate it could be a transition object, a missing link between the Kuiper Belt and the Weywot cloud, that distant shell of icy bodies surrounding the solar system. Its orbit's shape and inclination align eerily with models of how Neptune's gravity might have scattered debris outward during the solar system's violent youth, flinging some remnants to the Weywot cloud while others, like this one, lingered in unstable limbo. Then there's the mystery of its surface. Unlike the uniformly red-stained faces of many Kuiper Belt objects, 2021 DR15 shows patchy variations in brightness, possible signs of fresh ice exposed by recent outgassing. On a typical comet, solar heat vaporizes volatile ices, leaving behind darker, refractory material. If this object follows the same pattern, its brighter patches could be vents where gases erupted, uncovering pristine ice beneath. But without a closer look, it's impossible to know for sure whether we're seeing geological activity or just the scars of an ancient collision. The biggest question remains, is 2021 DR15 a Kuiper Belt native or an Weywot cloud refugee on a temporary visit? Its orbit's instability suggests it might not stay in its current region for long. Within millennia, gravitational nudges could send it spiraling further inward, becoming a proper comet, or slingshot it outward to join the Weywot cloud's ghostly ranks. Either way, its existence hints at a hidden population of restless objects shuttling between the solar system's frozen provinces, their migrations rewriting the boundaries of what we thought possible. For now, this cosmic drifter defies easy classification. It's a reminder that the Kuiper Belt isn't just a museum of ancient relics. It's a dynamic crossroads where the lines between comet, asteroid, and dwarf planet blur, and where every outlier like 2021 DR15 forces us to redraw the map of our celestial neighborhood. 2013 FY27 gleams like a diamond in the Kuiper Belt's darkness, a world so reflective, it throws every assumption about surface aging into question. Most objects this far from the sun wear dull, radiation-battered coats, their icy surfaces darkened over eons by cosmic rays and solar wind. But 2013 FY27 defies the trend, shining with nearly 50% reflectivity, brighter than freshly fallen snow on Earth. This isn't just a cosmetic oddity, it's a cosmic rebuke to models predicting how distant worlds should weather the harshness of space. The secret might lie in its partnership. 2013 FY27 isn't alone. It's locked in a gravitational embrace with a smaller companion, a moon whose presence could be key to its surprising brilliance. Binary systems like this are common in the Kuiper Belt, but here, the duo's dance may be stirring up fresh ice. As they orbit each other, their mutual gravity could trigger subtle flexing, heating their interiors just enough to force slushy water to the surface through cracks or cryovolcanic vents. Imagine two icy marbles rubbing together in slow motion, their friction generating just enough warmth to keep their surfaces glistening with new frost. But there's another possibility. 2013 FY27 might be a cosmic time capsule. Its high reflectivity suggests a surface dominated by pristine water ice, relatively untouched by the chemical reactions that darken most Kuiper Belt objects. If it formed in a particularly quiet pocket of the early solar system, sheltered from collisions and radiation, it could have preserved its original sheen like a photograph frozen in time. The trouble is, nothing in the Kuiper Belt should stay this untouched for billions of years. Radiation and micrometeorite impacts are relentless, yet somehow, this world has resisted their darkening effects. The implications ripple far beyond this one bright anomaly. If 2013 FY27's reflectivity stems from internal activity, it means mid-sized Kuiper Belt objects could be far more dynamic than we thought, hiding reservoirs of liquid or slush that occasionally breach the surface. If it's truly primordial, our models of surface aging need a complete overhaul. Either way, this binary system isn't just a curiosity. It's a challenge to our understanding of how time and space transform the worlds at the solar system's edge. What makes 2013 FY27 especially thrilling is how it mirrors and contradicts other bright Kuiper Belt objects like Eris or Makemake. Those worlds are larger, with gravity strong enough to hold onto thin atmospheres that might refresh their surfaces. But 2013 FY27 is smaller, lacking the mass for such processes. Yet here it is, shining just as brightly, proving that the rules we've pieced together from a handful of examples are far from complete. Every glint from its icy surface is a reminder. The Kuiper Belt still holds secrets that defy our expectations, and sometimes the most revealing objects are the ones that refuse to fade. 2003 AZ-84 spins with the lethargy of a world half asleep, completing a single rotation every 6.7 hours, a glacial pace compared to most Kuiper Belt objects. This sluggish spin is the first clue that something unusual lurks beneath its icy shell. While other similarly sized bodies like Haumea whirl like frenetic tops, 2003 AZ-84 moves with the deliberate grace of a much larger world, hinting at hidden complexities in its structure. The leading theory, this slow dance could be the work of an unseen moon's gravitational tug, gently breaking its rotation over eons like a cosmic hand pressing against a spinning coin. Then there's the matter of its surface, a spectral twin to Pluto in ways that defy coincidence. When astronomers analyze the sunlight bouncing off 2003 AZ-84, the signature matches Pluto's almost note for note. The same methane and nitrogen ices, the same reddish patches of tholins, even the same telltale dips in the spectrum where water ice hides beneath the frost. This isn't just a passing resemblance, it's a forensic match, suggesting these two worlds might have been born from the same corner of the primordial solar nebula. Imagine siblings separated at birth, one growing into the vibrant, geologically active Pluto we know, the other freezing into the quieter, more reserved 2003 AZ84. What's especially intriguing is how these shared ingredients have diverged. Pluto's ices are constantly reshuffled by weather cycles and geological activity, while 2003 AZ84's surface appears more static, its volatiles locked in place by the deeper cold. Yet recent thermal measurements reveal puzzling warm spots, subtle anomalies that could point to cryovolcanic vents or pockets of slushy brine trapped beneath the ice. If confirmed, it would mean this distant world isn't just a Pluto clone, but a unique laboratory for how similar starting materials evolve under different conditions. The real revelation lies in what these parallels imply about the early Kuiper Belt. The fact that 2003 AZ84 and Pluto share such specific chemistry suggests the region wasn't a uniform freezer, but a patchwork of micro-environments, each with its own blend of ices and organics. Some pockets might have been enriched by passing comets or the solar wind, while others remained pristine. By studying this slow-spinning time capsule, we're glimpsing the recipe book of the outer solar system, one where small variations in initial ingredients led to worlds as different as Pluto and its spectral doppelganger. Yet for all their similarities, one stark difference remains: 2003 AZ84's silence. Without the tidal forces of a massive moon like Charon to stir its insides, without the eccentric orbits that periodically warm Pluto's heart, this distant cousin has likely preserved its ancient structure in near-perfect deep freeze. That makes it something even more valuable than an active world, a control sample, a frozen archive of what Pluto might have been had history nudged it down a quieter path. Every slow turn of 2003 AZ84 carries echoes of roads not taken, of cosmic what-ifs written in ice and shadow. 2005 RN43 looms in the Kuiper Belt like a shadowy giant, one of the largest known objects in this frozen realm, stretching an estimated 430 miles across. But it's not its size that captivates scientists. It's the eerie, deep crimson hue staining its surface, a shade so dark it absorbs nearly all sunlight that touches it. This isn't the ruddy blush of Arrokoth or the mottled pink of Eris. 2005 RN43 wears a cloak of midnight red, as if dipped in ancient cosmic ink. The question haunting researchers isn't just what gives it this color, but when that transformation happened. Is this the original paint job from the solar system's birth, or a slow chemical scar carved by eons of radiation? The leading suspect, tholins, those complex organic gunks formed when methane and nitrogen ices are bombarded by cosmic rays and solar wind. On other Kuiper Belt objects, tholins appear as reddish stains, but here they've reached an extreme concentration, creating a surface darker than freshly poured asphalt. The sheer depth of this coloration suggests 2005 RN43 has been marinating in radiation for billions of years, its ices cooked into an ever-thickening sludge. Yet there's a twist. Spectral data hints at water ice buried beneath that crimson crust, peeking through in rare fractures. This dichotomy raises the tantalizing possibility that we're seeing layers of history, a primordial, ice-rich interior preserved beneath a radiation-altered shell. Then there's the puzzle of its reflectivity. Despite its vast size, 2005 RN43 is notoriously dim, reflecting less than 5% of incoming light. Most objects this large, like Pluto or Makemake, have brighter surfaces refreshed by geological activity or atmospheric cycles. The fact that this one remains so uniformly dark implies either astonishing surface stability or a complete lack of resurfacing events. If it's truly primordial, it could be a rare window into the Kuiper Belt's raw building blocks, untouched by the collisions or cryovolcanism that transformed its neighbors. But another theory challenges that simplicity. some researchers argue 2005 RN43 might be a refugee from even deeper cold, a transplanted Weywot cloud object. The Weywot cloud, that hypothetical shell of icy bodies surrounding the solar system, is thought to harbor darker, more carbon-rich objects than the Kuiper Belt. If gravitational chaos sent this wanderer inward, its exotic composition could explain both its color and its outlier status among similarly sized Kuiper Belt residents. The truth might lie in its rotation. 2005 RN43 spins unusually slowly for its size, completing a full turn every 13.5 hours. This lethargy could mean it's locked in a gravitational dance with an unseen moon, its leisurely pace allowing radiation more time to bake each patch of surface evenly. Or it might hint at internal structure, a loosely packed rubble pile that absorbs rotational energy like a cosmic shock absorber, its delicate balance resisting faster spins. What makes this distant world so compelling is the stark contrast it presents. In a region where bright, active surfaces dominate the headlines, 2005 RN43 stands as a monument to patience, a testament to what happens when chemistry operates on galactic timescales. Whether it's a preserved relic or a radiation-cured anomaly, its darkness isn't just absence, it's a record. Every photon absorbed by that crimson surface carries a fragment of the story, waiting for the day we get close enough to listen. Beyond the scattered lights we've catalogued in the Kuiper Belt, beyond even the strange orbits of Sedna or the Goblin, lies an unsettling truth. We've barely scratched the surface of what's out there. New Horizons' flyby of Arrokoth, formerly nicknamed Ultima Thule, gave us an intimate look at one frozen world, but it was just a single pixel in a vast, uncharted mural. Current telescopic surveys, as powerful as they are, suffer from an enormous blind spot. They're biased toward finding objects that are either large, reflective, or conveniently close. A dim, distant world the size of Mars could be lurking in the shadows right now, invisible to our best instruments simply because it doesn't reflect enough light, or because it's moving impossibly slowly against the backdrop of stars. Consider this: the Minor Planet Center currently tracks around 3,000 Kuiper Belt objects. Sounds impressive until you realize models suggest there could be hundreds of thousands waiting to be found, some so faint they'd make DD look like a spotlight. The problem isn't just brightness, it's angular momentum. Objects in highly inclined orbits like 2010 KZ39 spend most of their time far above or below the ecliptic plane where surveys typically focus. Others might be camouflaged against dense star fields or hiding in the glare of the Milky Way's core. We're essentially searching for a black cat in a coal cellar while wearing foggy glasses. Then there's the tantalizing specter of Planet X, not the sensationalized doomsday version, but a sobering mathematical possibility. The peculiar clustering of orbits among extreme trans-Neptunian objects like the Goblin hints that something massive, perhaps 5 to 10 times Earth's mass, could be shepherding them from the darkness. Simulations show a distant super-Earth in a stretched orbit wouldn't just nudge these smaller bodies, it would sculpt their paths like an invisible conductor. The hitch: if it exists, it's likely astronomically far, hundreds of astronomical units out, and chillingly dim. Spotting it would be like trying to find a lone street lamp in a blizzard from 10 miles away. But here's where it gets wilder. Planet X might not be alone. The same gravitational anomalies that suggest its existence could also hide a retinue of Earth-sized siblings, each drifting unseen beyond Neptune. Some theorists even speculate about captured rogue planets, worlds born around other stars, later snatched by the sun's gravity during a close encounter. These wouldn't behave like native Kuiper Belt objects. Their compositions and orbits would be alien, forged in entirely different stellar nurseries, the most humbling thought. We might already have seen such an object and dismissed it. In 2016, astronomers reviewing old Hubble data found a faint dot moving imperceptibly slowly, so slowly it had been flagged as noise in previous searches. Later designated 2014 UZ224DD, it turned out to be a substantial world nearly 400 miles across. If something that size slipped through for years, what else might we be missing? Technology is racing to close these gaps. The Vera C. Rubin Observatory, set to begin its legacy survey of space and time in 2025, will scan the sky with unprecedented depth, catching movement across millennia in a single night. Even so, the outermost Kuiper Belt, let alone the hypothetical Weywot cloud, will remain stubbornly opaque. For every object we catalogue, there could be a dozen more hiding in the noise, their existence only betrayed by the subtle warping of space-time or the occasional flicker of a background star. This isn't just about filling gaps on a map. Every undiscovered world is a puzzle piece in the solar system's origin story. A single Earth mass object beyond Pluto could rewrite our understanding of planetary migration, while a captured interstellar interloper would prove our cosmic neighborhood is far more porous than we imagined. The Kuiper Belt isn't just a collection of icy leftovers. It's a frontier where known physics collides with the whispers of the unseen, and where every new discovery reminds us how much we still don't know. From Arrokoth's primordial stillness to Quaoar's impossible ring, from Pluto's beating heart to Sedna's lonely exile, these 25 objects aren't just oddities. They're revolutionaries, each tearing at the edges of our solar system's instruction manual. Take Haumea's dizzying spin and razor-thin ring, defying every rule about how small worlds should behave. Or Gong with its sluggish rotation and fleeting whispers of atmosphere, proving that even in the deepest freeze, chemistry refuses to sit still. Consider Ixion's crimson stains and 2005 RN43's midnight hue, two worlds painted by radiation, yet wearing their colors in wildly different ways. The Kuiper Belt isn't some orderly museum of fossils. It's a riotous gallery where each exhibit clashes with the next. What unites them all is their stubborn refusal to conform. DD's thermal glow hints at hidden activity where none should exist. The Goblin's skewed orbit points to gravitational ghosts we can't yet see. 2021 DR15 blurs the line between comet and Kuiper Belt relic, while 2013 FY27's icy radiance mocks our models of cosmic aging. These aren't just scientific curiosities, they're urgent questions carved in ice. How does Makemake lack an atmosphere when Pluto, its near twin, brims with one? Why does Varuna spin itself into a frenzy while 2003 AZ84 lounges in slow motion? Every anomaly is a crack in the foundation of our understanding, and behind each one could lie revelations about planet formation, organic chemistry, or even the seeds of life itself. The most thrilling realization: we've barely begun. For every mystery solved like Arrokoth's two-lobed shape, revealing how planets grew gently, dozens more erupt. 2008 OG-19's tumbling form and 2010 KZ-39's orbital rebellion suggest forces at work we haven't even named. And lurking beyond them all, the tantalizing specter of Planet 9 or other unseen giants, their presence felt only through the gravitational ripples they leave behind. This is why the Kuiper Belt demands our curiosity and our spacecraft. Imagine a fleet of probes, each visiting a different class of these enigmatic worlds, drilling into their ice, mapping their chemistry, listening for the echoes of their origins. The data they'd return could rewrite textbooks overnight, but until then, we're left with fragments, pixelated images, spectral hints, and the exhilarating certainty that out there, in the dark, the solar system is still inventing itself. So keep watching the skies, because the next great discovery might not be a dot in a telescope, but a revelation that shatters everything we thought we knew. The Kuiper Belt has only just begun to speak. Who knows what it'll say next?